So we have what we call a natural exponential function. It's an irrational number, which we refer to as the letter E. And it just arises naturally in a variety of phenomena and plays a central role in the mathematical description of the universe. It's in the topic that's referred to as growth without bounds. So it is often used in kind of population problems, which has growth without bounds, and it's used in finance applications a lot. It's what we use to refer to our continuous something like. So for finance, it would be interest compounded continuously. It's always being done kind of a thing. So it was found by Euler, which is why they use the letter E for it, because his name starts with an E, who was alive from 1707 to 1783. Kind of history for you. And he introduced the number we now know as E. So E approximately is the decimal 2.718281828. Dot. It keeps going on forever, and again, he just kept doing a whole bunch of problems back in the day. And every time he did these problems, this number just kept appearing, and it kept showing up, and it kept showing up, and kept showing up. So he realized it's just something that exists when he was doing his calculation. And that was the value it equals. Bless you. So we do need to evaluate sometimes our E, and it's actually quite simple to do. If you go to your calculator, make this a little bigger. You see this button here that says LN? Right above that button in blue, there's your E. So if you have to evaluate E, all you have to do is use that button. So our first one we have to do is e to the negative 3. So I'm going to hit second, and then the ln, and that brings up my e to my little exponent, and then I'm going to type in my negative 3. And that's what we get there. 0.049787. 0.0497870684. So then e to the 0, do we really need a calculator for that though? Anything to the 0 is what? 1. So that one's just a 1. So let's have you practice using this E button. So go ahead, do the other one. Type in there e to the 1/6 and copy down your decimal. And then 2.7 e to the, that's a 0.43. Type those in your calculator, practice the button, write your decimal down. So then, plugging into a function that has e, same as plugging into any other function here. They want us to find f of 7. So we're just going to plug 7 in for our x, which happens to be up there in our exponent spot times the 0.28. And then we'll just use our calculator. 3.54 e to the 0.28 times 7. So hopefully you got 25.13161781. And then our last thing with E is sometimes you will have to draw a graph of E. So it's just like anything else. Use your calculator, help you get your graph there. So we're going to graph E to the x power. So I'm going to set up my table. We're going to copy down a few points. So go to your y equals. I want e to the x, so I'm going to hit second ln. And then just put my x up there so I get my e to the x. If we look at the graph, what kind of graph does it look like? It looks like an exponential because it is still an exponential. Your x is up there in the exponent spot. And instead of like a whole number like we were doing last time of like 2 or 3 or 4, or 1/2, even a fraction would work. We just have that letter e, our irrational number e. So it's always going to have the same shape. So if we take a look at our table, the only problem with this one is we're going to have a whole bunch of decimals, so we're going to do a lot of estimating. So I'm going to start with negative 2.35. 0.1353 and negative 13679. Zero is a nice one at 0, 1, because anything to the 0 power again turns into 1. And 1, 2.7183. There we go. That should be enough. So again, we're just going to be estimating with our decimals. I'm going to start with my 0, 1 because that one's nice and easy to graph. And then 2.7 is a little more than half. 7.3 would be a little less than half. Again, decimals just estimate. What's the one thing missing from my graph? We had to draw it with all of our other exponentials, so we have to draw it in with this one also. Now draw on your asymptote line. So for this one, our asymptote line is at 0. Remember, if you move it up or down, that's what changes that line. So first question, what is the domain? So we've got arrows on both ends. This will continue on forever. So our domain can be everything, so we can say that as x is an element of the reals, XER. Or some people still prefer negative infinity to positive infinity. It doesn't matter which one you use. Our range, remember, is our y values. It's all above that that x-axis there. So y has to be greater than 0. It can't be 0, because remember, that's where your asymptote is, so it cannot be 0. So it's got to be greater than 0, not equal to. Our y-intercept for this one would be at 1. And then our horizontal asymptote, like we said, is at y equals 0. So just like our other exponential graphs, just kind of continuing that.